Hello everyone. Today we are going to talk about our first class, our first lecture in our course Digital Signal Processing with Python. So we will start with the very basic fundamental concepts like sampling, quantization, and aliasing. You will hear them a lot when you will deal with digital signal processing. Whatever the tool you are using, Octave, Python, or MATLAB, so you will hear them a lot. So let's take one by one and introduce it. Sampling. First of all, you need to know that signals in general are analog. They are from sensors, which are analog, like temperature signal. They are in volts, electricity. They are like the sounds in your headphone. They are also analog from a sensor in millivolt or volt or whatever the degree of voltage it uses. So in order to make some processing on them on computers, we need to digitize them and store them in registers. We do so by analog to digital converter, which is an IC. It digitizes the signals into samples. The analog to digital converter takes reading on every periodic time interval called sampling time, which is T. Here it is, the samples. This is the original signal. As you can see, it is continuous. And this blue and these red dots are the samples that are taken to be saved into registers. And this is the sampling time. And they represent this reading in quantized format. These that are quantized means they are rounded to the nearest possible value that can be held in a register. The second concept is the Nyquist frequency. What is the Nyquist frequency? We cannot choose the sampling rate whatever we want. We need it to be twice the sampling rate of the signal frequency. For example, here in this signal, we have signal of we have this signal. What if we took three samples, which means sampling frequency of 2, and the signal itself is 2? You will find that we represent a line. So it's not valid. We need more sampling in points. So we need the sampling frequency to be more than twice the signal itself, sampling of signal itself. This is a request frequency. To represent signal, the minimum one is twice the signal sampling frequency of a signal. Aliasing. It happens when we don't follow the Nyquist criteria. Here, as you can see, this is a signal in red one, and these are the sampling point. If we take sampling point lower than the sampling frequency of twice the sampling frequency of signal, like this one, the blue dots, will represent a fake signal. As you can see, we make a signal that does not existed. So it's totally wrong. We need to what should we do? Usually we use low pass filter in analog format before the digitization. It lowers the frequency component of the signal, or use a higher sampling rate. Either of them are fine. It's design dependent decision, because sometimes you don't want to lower your frequency band of the signal. You want to save some frequencies. So in this case, you should use higher sampling rate. Quantization error. ADC rounds the data. So if we have 8-bit representation, we'll have 8-bit accuracy in the range from 1 to -1. The system is 1 divided by 128, which is this number. Is the minimum value can be stored. So if we want to represent, for example, this value, the ADC will round it to the nearest possible value that can be represented. It will be round to a half, which is this value in binary format. We represent data in 1 and binaries. The error is very small from this to this. The error is very small, and the error percentage of the signal level is very small, which is accepted. But what happens if we have a very small value like this one? Will it be represented? The minimum value to be represented is this one in 8-bit bit accuracy representation. The error percentage to the signal level is this one, which is very high. This is called quantization error or quantization noise. The solution is to use higher bit representation like 16-bit to get more resolution. Here, this value will be represented as this one in binary format in 16-bit resolution, which is this value in decimal. This one is converted to this one. The error percentage to the signal level is uh, this value 1.0 percentage, which is acceptable. So now you understand that the value is quantized, the value is rounded. So some data are lost. This is called quantization noise. It should be small to be accepted. Thank you for your time.